Good morning. Today's video is about a signal gen I got from TomTop, another Chinese company. They contacted me a while ago and asked me if I want to make a review of one of their products. And they let choose me what I want to do. So I need a signal gen. The one I have is not so good. And I choose this one because this one is a panel mount. I can build my own case around it. And this is JUNTEK JDS2800, and it is the entry-level one. Okay, all of them are entry-level. This is the 15 megahertz version, and it goes up to 60 megahertz for only a few bucks more. This is at sale at the moment at $65 US, so quite cheap. It has a nice display, and it's a DDS. It's a signal gen, also direct digital sampling or digital direct sampling, whatever it means. In a ROM storage there is the waveform, and then it just have a digital analog converter and put it out. So very simple operation. I don't know how precise it is or how good it is, but for my lab with cheap components, it should be good enough. It arrived very quickly. I don't know how they sent it. I know they sent it with DHL, but it only took 3 days from China to Germany, so quite fast. Not often the Chinese products come in boxes. This one came in box, in a brown box, nothing else. And what's inside the box? Standard wall plug. From the feel, and I think from the company they have here, it's DVE. I see this also at more expensive products, and it doesn't feel like the cheap Chinese wall plugs, so this I will keep. It has 5 volt and 2 amps, so very standard. Then we have in the box the signal gen itself. Here we have one of the BNC leads with the 2 crocodile plugs, crocodile somethings. We have a BNC cable, quite short, about should be 40 or 50, no, 40 centimeters. USB lead, yes, you can attach it to the computer. You can install some software on the computer, and then you can write your own signal form, so that you can edit the signal form and send it to the device, and you can just use it as the source for the DDS. There's the CD with the software and a user manual. Not the user manual. Get away the box. Get messy on the table. So open the package. Comes very well protected, and this is the JUNTEK itself. It is quite bigger than I thought on the picture, but I like it. It has a good size, and you see here, maybe you can see, it has the, yeah, you can just mount it into your own case. And that is what I want to do. I want to design a case for it, like my standard cases, like the one I have here, like this power supply, just a little bit larger so it can fit in. And of course it will be battery powered, as a lot of my lab devices is a lithium battery, and because this runs with 5 volt, it will be very easy. I have this battery pack here from a power bank, and should work a while with it. But this is not part of today's video. Today's video is just a quick look around. How does it work and how does it perform as good as I can test it with my equipment. I have a cheap Sigland oscilloscope, so it is of course not like Dave Jones with a lot of equipment and he can say, oh, this is blah and very slow, but we will see how good it performed for a hobby lab with low budget. So this is a low budget product, but looks nice and it has all the functions I need. It is a 2-channel one. So next part of the video, we just turn it on. We don't take it apart yet. Later we take it apart, of course. We want to see what's inside. So I just set up the table and wait a second. Hey guys, welcome back. So just set up the table with the oscilloscope and the JUNTEK JDS2800. The oscilloscope is a Zigland SDS1072. I have a while ago make also a video from it. It's a bottom line oscilloscope, nothing fancy pantsy, but for my things it's okay lah. The same like the JUNTEK. I already play around a little bit with it. The user interface is okay. You don't need a manual to use it. Maybe only for the modulation stuff later to it. So what do we see here? We set up a 1 megahertz sine wave with 5 volt peak to peak voltage. Voltage halt, okay? So, and it's very easy to change. You have here the soft keys. At the moment, the first one is for frequency, amplitude, offset, duty, and phase. So what do I want to change? Not we, I change it. You only watch it. I want to change the frequency. Just now I'm at 1 megahertz and I will go up to 2 megahertz, 3 megahertz. And when I want 3.5, I can just go left and right, add the digits. So 3.5 megahertz signal now, and I can change the time base on the oscilloscope. So the oscilloscope frequency counter tell me 3.4999 megahertz. So it's okay now. It's sure it's okay. This is a 2-channel 1. So at the moment this is the setting for the channel 1. The channel 1 is set to 10 kilohertz, and you can see on the LED here it's already on. So just get another lead. Plug it into the oscilloscope, plug it into the signal gen, switch on channel 2, and it is at 5 volt, then, but you see it show very slow because this is 3.5 megahertz, not gigahertz, and the other one is only 10 kilohertz. So at this time base, you cannot really see what's going on channel 2. So I can do 2 things. I can change the time base on the oscilloscope. Then you see the 3.5 is just showing yellow now. And because I'm triggering on channel 1, you can see the channel 2 is a little bit drifting. At the moment, these 2 channels are not synchronized or not totally at the same point starting triggering or something like this. So what should I do? Okay, I would change the frequency on channel 1 so we can have a look at both channels. Zero is a little bit. Now I have both channels at 10 kilohertz, and because I do this to show you something what the other functions do, like amplitude. And I'm playing with the settings for channel 1 because this has the bigger display. I'm changing the amplitude to 5.5 volt, maybe a little bit more so it's better to see. And here you can see what happened when you change the amplitude. The sine wave goes up a little bit, and to -3 to +3 volt, 6 volt, peak to peak. Just remove this menu. So then we have offset. Offset is like we're putting a DC on an AC or an AC on a DC. So if I set the offset to 0.5, you can see the yellow waveform is just shifting up because I'm applying a DC from about 1 volt. So this is still the same sine wave at 10 kilohertz, but with an offset from 1 volt, so, and 6 volt peak to peak. So it is getting higher. Then what else can we change? Duty. I don't think that the sine have a duty cycle. I think this is for pulse or something, but we can try it if we can see it. No, you see, there's no different at the sine wave. I cannot explain why, but I think remembering only the pulse or this one. Didn't remember yet. Oh my gosh. The square wave. It's a square. You're right. The square wave. So phase. The phase angle you can only change on channel 2. If you change this, well, that is a little bit. I want higher change. You can see it comes earlier or comes later, so we can bring it out of phase. It's better to see maybe when we change the frequency, the amplitude again to 5, so both signs are the same. Now we go back to phase and I change it to an I want 180 degrees phase. So you see the blue waveform is in 180 degrees phase change, so comes 100 degrees earlier or later whenever you start to look at it. When you have the third one and put a 180 or 120, 120, 120, you have a 3-phase AC. That is something like in Germany when we put on an oven, we have a 3-phase AC, but my oscilloscope cannot do 3 channels and the DDS cannot do 3 channels, so I can't show you. But that is something like a 3-phase AC, and you have a phase shift from 120, 120, 120, so it's 360, something like this. So what else can I show you? I go back to the frequency and I want to change waveform from channel 1. So we go to square. You see channel 2 still a sine wave because both channels are independent. Pulse is the same like square, but you can change the duty cycle on it. Triangle, yeah, classical triangle. Partial sign, I have no idea. Maybe I should read the manual, but not. CMOS is just like your standard CMOS circuit. You have 0 to 5, or it's like a square wave where you put 5 volt DC. Yeah, DC. What is DC? Of course, it doesn't show because I'm coupling AC. Don't change it yet. So waveform. Half wave, yeah, that is if you're using a single diode on a sine wave or on an AC, you get a half wave. And all of your electronic aficionados or who like electronic, you know this is the signal you get from a full bridge rectifier. Next one is positive ladder. You see like working up, you're on the top, and then you get a negative ladder and can go down. Noise, yeah, what is noise? Just random stuff. Exponential rise, it's a function. Decay, the same. Multitone, zinc, and something like a sine wave. Lorentz, arbitrary. Yeah, I already loaded an arbitrary. That is chaos, this one. But arbitrary, it's very useful. You get a computer software with this where you can change the waveform. So yeah, very nice. I have to say I like it. So what else can I show you on this? Just let me think a minute and then I'm back. I think I already know, but I need to prepare something. Okay, see you soon. So welcome to the third part of it. I'm just playing around a little bit and you can see some basics or some complicated parts or why a square wave is not the most easiest waveform. Not for the oscilloscope and not for the generator. A sine wave, even it looks more difficult to draw, it's more easy because you have this on a square wave. You're getting from minus or from 0 to plus, and this should be happen in no time. No time never work. So I want to see how fast this generator is. And I tell you, I play around a little bit with it, so I know it's not bad. So I go to the fastest setting, or the best, the lowest setting time base my oscilloscope can do, and that is 5 nanoseconds per division. So already at the first look you see we have about 10 nanoseconds from 0 to the high, or from low to high signal. That is quite fast. 10 nanoseconds is like nothing. Okay, for me it's nothing. For other people it's maybe something. For me it's nothing. I even don't know how short it is. So, but what depends on the signal form or how the signal look is also the cable or the things you use. Here I'm using a not very high quality BNC to BNC cable with just a coax between. For channel 2 I use this very weird construction. No, it's 2 BNCs going, one going to a banana plug, the other one going to crocodile clips. So very not good for the signal, and you can move it. That is what I like. So what happened? I have on channel 2, I have the same signal, 100 kilohertz at 5 volt peak to peak, and I will switch on channel 2. And you can see what happened already. And if I just change this to, you will see the yellow one has this weird thing and not the blue one. So you see, because of the cable is not perfect, it's really not perfect, both cables are not perfect, but this cable is more worse. It is overshooting here. It is not really stable like this. It's just overshooting. It's going higher. And if I play around with the cable here, you see even at 100 kilohertz, that is not a very fast signal. You can see it's already changing a little bit. Not so much, but it is changing because the race is a very high frequency. So, oh, maybe what happened if I bring a magnet? Oh, yeah, wait, let me see. Just making this with it, and then, oh yeah, I'm playing with the magnet here. You can already, you can see also change. So that is why square waves are more complicated than sine wave, because when I switch to sine wave, let me see what happened. Sine wave on, nothing happened. Oh, maybe I'm on the wrong frequency. Yeah, you will see. Then channel 2 also wave sine 5 volt, 5 volt. Where is my mistake? Oh shit. No, it's not this. Oh, the time base was set so high, and on a sine wave I don't have this very fast thing, so I didn't see. Could happen. Oh wait, let me check the focus. I have a little bit problems with focus always. So here on sine wave, and when I go closer, I was too close, so I only see this part. You see, it is just a slow rise, a slow fall, so this is not a problem. And you see at 100 kilohertz, no difference if I use this cable. Even I think when I open it, no, I have the same thing, and then get me this long spool of cable. It is a lot of cable on it. And now you see why I want a signal gen. With a signal gen, even I have no project where I really need it for measuring or inserting some signal. It is great to play around, it's great to test things and to understand the basics of electronic and frequencies and all this stuff. And this, don't find the other side on this cable, so I can't use it. But I can drop it. Let me see. I have this one also. One side of the cable. I know it's getting a little bit lengthy and you maybe get boring. Don't worry, the next part will be the tear down. Just have a look inside. Okay, I have this long cable. Then attach one side and the other side, and you see only thing happened is I have not a good contact. the voltage drop a little bit. Even I just... it's okay. You see, there's no big difference between these two, even when I go closer. But now, when I switch back to the square wave, there's a square wave on channel 1, it's okay. And now go to channel 2 and switch on the square wave. Things happen. Very funny things happen. Because now we're inserting some, that should be induction. Yeah, it's just a lot of cable and it's an induction. We put in an induction, and this point where the frequency rise or the voltage rise, it's a very high frequency, and you see the reaction of the induction. It was charged up and then it started to oscillate. So here we have a higher frequency than the rest of it. And if we just increase the frequency, you should see it's getting worse and worse. So this is not looking anymore like an square wave. So you see the square signal or the square wave signals are a lot more affected by the quality of cables, quality of connections, the shielding or inductions, or even when I put in, let me see, I think I have one of my boxes should be a capacitor. Not an electric one here. Very standard one. And this I will put also in series with the rest of it. Need a second crocodile. Let me see. I just changed this cable from the 4mm bananas to a crocodile clip, so I can put in more things. Okay, this part of the video, just think it's ended already. Only if you want to watch or still want to watch, you can watch it. So, because at this point then I say thank you to TomTop, another Chinese company, for sending me the JUNTEK JDS2800. Guys at TomTop, you can see I have a lot of fun with it, playing around. What did I do? Oh, don't say any. It's not good to talk and take video and but it's a great toy. Yeah, really great toy. So you can see here now. What do we see? We have, or I have, bring in the capacitor in series to the signal. You can see the overshoot is higher than just with the short at the line here. No, doesn't change any. Oh, wait. Yeah, it's a capacitor. It's like unsichtbar, like invisible for high frequencies. My failure. So then I bring back the induction. The inductor, the thing. I like this, really like this effect. What happened? What do we have? You can see a lot of overshoot here on the display, just with this, and should also be affected by, maybe it's affected a little bit by the magnet. I cannot move it fast enough that you can see something, but it's okay. What else can we do? Maybe with two different kinds of waveforms, I can switch my scope to XY mode. Where is it? Display? Display night? Cursors night? Measure? Utility? No. It should be on acquire. Sin X, no. I'm sure it has this mode I'm looking for. Oh, more pages. There, XY mode. So now the channel 1 is an X and channel 2 is Y. So what will I prepare? I will prepare 2 sine waves. I don't know why. I like the sine. 2 sine waves at the same frequency. Channel 1. What I say? You have to think about a little bit about the user interface, but it's really not bad. So switch back to XY, and you only see something like this because we are in phase. Now I change the phase angle by 10 hertz. So I think at 90 degrees phase shift between the 2 sine waves, I get a circle. Oh my gosh, I paint a circle on the... Okay. Maybe we can do a little bit like an animation. Oh, should make it frame by frame. If I take single pictures for this thing, I can make a very nice animation. Okay, you know there's this music stuff where you can paint pictures with it. So what happened if I change the waveform? Channel 2, we go to an square. Okay, we get a square. Just joking. Then what else can we... Oh, go to the noise. Yes, I like this. It's almost a picture. I have no idea what it shows. Maybe I can zoom in a little bit. And with the visions, you can do like zooming in. Yeah, that is what this thing is just doing. Oh, it's the arbitrary, not the noise. Okay, it's the arbitrary. I painted in it. Just make this beautiful picture. Maybe I should save a screenshot on the USB. No. So, thank you again to TomTop. This is just the first 3 parts of the video. I show you the JDS2800. I play around a little bit with it. The first play around was just normal stuff. Now it's just blah 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 stuff. I hope you enjoyed and give me a thumbs up or whatever you want, or just leave a comment. Yes, just leave a comment. Write something. Next video from this device is the teardown. And then I prepare also another video with my daughter. Later I go up and my wife will take video for us with Sophia. We have to assemble the Odroid Go blah blah blah. Okay, see you next time.